Hi everyone, this lesson is coming to you from Education for All. Visit our website https://educationforallsl.co.uk, and there you can get a lot of information. There you'll be able to contact us if you need help with assignments, with essay writing, dissertation. Then you can contact us directly from our website. We are going to look at trigonometry, in particular graphs of sine, cosine, and tangents. We are familiar with these trigonometric identities, the sine, cosine, and the tangent. But what we are going to look at is how to plot these functions. We should be able to graph them. If you are given a trigonometric function and you're asked to graph it, you should be able to do it easily. That's what we are going to do. We are going to look at the graph of the sine function first. We'll investigate it, we solve problems on it, then we move to the cosine function. We'll do the same thing again, investigate. What I mean by investigate, we study its properties, and then we move over to the tangent. The function y equals sine theta is represented in this form. And this is just a function or an equation to say, but in practicality, how do we use it? What is its benefit? Well, the sine function is used to represent sound and light waves. Sound, play guitar, that's sound, and the rays of the light. Waves, so we use the sine function to represent those waves, the sound and light waves, especially in the field of physics. And properties, let me just say properties here. Ti of sine function. One, here you can see, the phone is ringing, sorry about that. Okay, you can see the range of the sine function. It ranges from 1 to -1. This is the range from 1 -1 to say, let me just say -1 to 1. The range, the sine function, from -1 to 1. It cannot go beyond these two values. What that means, you can have a maximum value of 1 and a minimum value of -1. It stays in that range. between 1 and -1. It can go below, it can go above those two values. It can go above +1 and it cannot go below -1. It always stays within that range. So that's the range of the sine function. 2, let's look at the domain of the sine function. That is, by how far does it go on the negative and positive x-axis? How far does it extend this side and this side? Well, the domain of the sine function starts from infinity plus minus infinity to plus infinity. That is, it doesn't stop. Keeps on going. If it is going on the negative x-axis, it will keep going non-stop. If it is going on the positive x-axis, it's going to infinity. Infinity is actually, it's not a number. So it's just an imagination of how far something can go. Just keeps going. You can't give it to a number. So that's infinity. Infinity on the left-hand side and infinity on the right-hand side. And it has a period of 2 pi. What that means, if you draw a circle, one revolution of the circle is 360 degrees. That is what we mean there when we say it has a period of 2 pi. This 360 degrees, you know, is equals to 2 pi. These two are the same. But mostly we use this symbol, pi. It's simpler to solve with than it's 360 degrees. So that is a one circle here. When you want from this top here to this top, this forms one revolution. It forms one turn. So this is 2 pi. From this top to top is 2 pi, 360 degrees. So that is the what we just mentioned here, 360 degrees, and it's equal to 2 pi, and this is what we call the period of the function. It repeats every 360 degrees. That's what it means, period. Every 360 degrees, you get this same appearance of the graph. Whenever it completes 360 degrees, you will get this same representation. Whether on the right hand side or on the left hand side, you get the same representation every 360 degrees. So its period I is 2 pi for the sine. And also some interesting thing, just want to make mention of. You will come across it, probably not in this topic, but it's worth noting. It's better to know it. That the sine function is an odd function. The sine function is odd. What does that mean? It starts from 0 here. That is, it doesn't have a reflection of, when it starts from 0, it starts from 0 here, right? It doesn't have an exact reflection on the left hand side. What does that mean? If you look at a graph like this, say this is -1, this is +1, and then it starts from here, goes like this, like this, like this. Here again, it extends like this, like this. You can see that it is, my graph is not perfect. This is your 0 point here. This is the 0, the origin. You can see that this is symmetrical about the y-axis. Your graph is symmetrical. That is, this function, this part here is a reflection of this part here. Symmetrical. We shall do a graph that is symmetrical about the y-axis. But the sine function starts from 0, so it's not symmetrical about the x-axis, the y-axis, sorry. So therefore, it's odd. A graph like this, wherein is symmetrical about the y-axis, this graph is even. These are the graphs we call even graphs. You have like the cosine function is even because the cosine function behaves like this, while the sine function starts from here. So it's odd. Right? So far, this is what we need to know about the sine properties of the sine function. What we're gonna do now, we're trying to plot or sketch graphs of the sine function and different graphs. Then when we have a graph of that idea, then we move over to the cosine function. Thanks for watching. Bye bye.